Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour.
Hello and welcome back to another episode of our podcast On Air, Actually Rocket Science, facilitated by the Student Council of Aerospace and Geodesy. I will be joined by my co-host, Mikkel.
Welcome.
And our guest, Professor Dr. Martin Werner.
Hi.
Would you like to introduce yourself?
Yes, if you want. So my name is Martin and I'm here a professor for topics related to big geospatial data. And inside the Aerospace Bachelor, for example, I'm teaching computer science foundations. And inside Geodesy, I'm teaching more algorithms for handling very large data sets. And yeah, I'm happy to be here.
We're doing a quick warm-up, like some this or that questions. So keyboard shortcuts or mouse?
Keyboard.
C++ or Java?
C++.
Python or MATLAB?
Python.
Cats or dogs?
Cats.
Google or DuckDuckGo?
Google.
Okay, very interesting. So we dug up a little bit of your past and actually found out that your first field of studies was mathematics and not informatics, in fact.
Yes, that's right.
So we wanted to ask a question, why did you start with mathematics and what motivated you to go in that first?
It's just one of the most beautiful ways of thinking about science. It's just very clean. If something is found out, it's just true or it's not. Very binary, very clear, and it's just very aesthetic.
Yeah. So afterwards you switched then to computer science. Where does the change of interest come from?
Actually, this was not a real change of interest. So when I was doing mathematics, I was doing a lot of geometry and topology. And then my wife started learning something in Munich and I wanted to follow up. So I was just looking for positions that would accept me. And I found a PhD position in the area of indoor navigation. And indoor navigation is quite interesting in terms of geometry because very basic properties like the triangle inequality just don't hold. For example, when you have a staircase and an escalator, even though the staircase would provide you a shorter path, maybe it's smarter to go to the escalator a few meters and use it because it's so much faster. So in the end, it's just geometry. And this actually is also the way to explain everything I did, because afterwards I was just working on geospatial data until today. So yeah, it's all the same, but from a kind of different angle.
But we also found out that after you were a postdoc at LMU, you also worked for the DLR, which was basically then the geospatial data, or?
Yes. Actually, I was going from LMU Munich, where I did a postdoc. This was the time where my first son was born, and I didn't want to change universities, so I stayed quite long after the PhD in LMU and taught computer science, mobile computing, and distributed systems. And then I went to Hannover University for the topic of big geospatial data, and from there to the DLR in Oberpfaffenhofen, where I was working mainly on social media data, which is also the reason why they hired me, because typically they worked on radar data and on images, but they found out that social media might be interesting, and social media was much more geometry, much more about people, much more complicated, different toolings. So I kind of had a time there setting up social media analytics for the DLR, and from there I went on even to University of the Armed Forces here in Munich, giving again some more foundational geoinformatics. So this was also a position related to cyber defense, but mainly just geoinformatics. And then I went to TUM, as you know, for big geospatial data.
Is there a difference between the University of the Armed Forces and TUM?
Yes and no. So, of course, the problem of the University of the Armed Forces is that the students are not there to become PhD students. So they are just educating, like, for example, in Germany, the Fachhochschulen. So you have smart students sometimes, but typically the students after the time of study have to go to the military service. So even if you have very nice people there, you can't hire them for a PhD. So you have kind of this gap that you educate for nothing. And there are also not so many students then you can hire from.
Interesting. And here at TUM, you are also not only working here for your professorship, but also teaching as well, right?
Yes.
So we wanted to ask a little bit about your experience and how did kind of teaching help you to grow as a professor or as a person, or did it not? Or do you think that has somehow benefited your career in some sense as well? Or
yeah, I think teaching is essential, and we have this unit of research and teaching. So I don't think that there can be a single researcher that is a good researcher without being able to teach. So even students should teach, for example, in a seminar, teaching each other or as a student tutor or whatsoever. So teaching is just, if you want to be a scientist, it's just required because it's just science communication, and it's a good playground, a good place also for science communication. Because in the end, in a conference, you have to do the same, just with a little bit more abstraction or a little bit more of expected background. For me personally, teaching was always very nice because students are always friendly and they're always there. So when you're frustrated from like a failed research thing, you can just go to the lecture and be happy. And vice versa, when the students are getting annoying like a few weeks before the examination, asking lots of questions that do not make too much sense, then maybe you have a good research result. So it's also like a social balancing system that you have like two identities, one as a teacher, which is very good, and one as a researcher, which is very good. So I think teaching is essential. Everyone who's not teaching cannot be a good scientist, because in the end, my PhD students, they are always asking questions. They always need to learn something. Yeah, more from the domain, maybe more specific, but yeah, science is nothing without teaching, so teaching is good.
This may be very far-fetched, but I think we want to create a link to another topic, which we think also can be very strongly correlated to asking a lot of questions, and that would be ChatGPT. Have you ever heard of it?
Yes, of course.
Can you maybe explain to us how it works?
Yes, I can try to give you a sketch also how it emerged. So in the past, when we did text mining, basically you just set up a table and you select some words where you think they might be important. So you remove very frequent words like the and all these small words. And you also remove all the very rare words, which you just observe one or two times because they don't give you information. So you kind of model then your documents or your sentences, whatever you have, just by looking which words are inside. And in fact, with the rise of deep learning, one has tried to do the same, but without really selecting the words. By letting like an abstract machine and some optimization technique create such a table, very similar. Now it's not just the word is fully inside or not, so 1 or 0, can be any number, but in a sense, everything says that that the sentence you were giving to the system is kind of related to a concept or not. But the concepts are automatic, so we can't interpret them. And this was very powerful. These were the so-called text embeddings. You could do lots of things with them, and there were surprising properties. For example, that they support addition. So what you in the end get is you put a sentence or a word to it, like queen, and then you can take a second word, like male, and you can actually write something like queen. You get a vector, like minus female, you get a new vector, plus male, and the vector is surprisingly near to the word king. So somehow, by accidents, we realized that statistical learning can find such patterns, which are grammar or semantical patterns. And these systems were basically trained by taking lots of text and removing a word, so you had some context and you try to predict that word. And then the transformers emerge where you say, why should we actually just take something and look once at it? So giving one word at a time and always updating some internal state. And on the other hand, from this internal state, so just some very large vector emitting new words. And then you had the translation machines. And ChatGPT is just a fine-tuned transformer model in a sense. So it's just this strategy. You give in all the words and you let it emit words, and it looks like it's intelligent, but in fact, it's just statistics. It's just showing you something it has frequently observed.
So in a sense, we observe a lot of people nowadays saying, oh yeah, ChatGPT will be the big new thing and it will replace all the Google like searches because it is a fact that people have definitely started searching in ChatGPT than in Google, because already Google had this implementation where when you would search something, it would give you directly the answer and not only the tabs, but that was not even enough. So they kind of switched to ChatGPT. And do you think that it really has a prowess, or maybe it's kind of more of a trend and will maybe fade?
I think it will neither fail nor be useful. The point with these models is they are just too large. Right? It's just not possible to kind of use them for everyone in the world for like 10 searches per day. But of course, they are good tools when you have a large body of text like the internet, or even some domain specifics like all contracts of your company. Maybe you want to have such a model. And what is really new from a user perspective is that this is a chatbot that works. So you have some context. When you think about Google search, you start with a search. It's a bad one. Maybe you search for something that has multiple meanings, and then you refine the search, and then you refine the search, and so on. But it's not like Google is remembering all this track and helping you to find what you're missing. So it's more like this dialogue nature, what people are looking for. But this dialogue nature can be implemented with ChatGPT or with other systems. So I don't think it's really a disruption in the sense of how we will use the internet, just because it's too expensive. It won't scale to everyone, but it's a good addition in the toolbox. And actually, Google search is not keyword search since years, right? As you said, it's not only giving answers, it also uses a predecessor model of GPT to kind of augment the search space. So we will be somewhere in the middle. For most of the searches, the keyword search, as it was in Google or in AltaVista and all the old engines, is just enough. So we will stay with it. But for some things, maybe it's good to have like this chatbot logic where you can refine things and where you can ask back or you can ask for precisions. And of course, university teachers fear that written things are even more difficult to evaluate. Right? In the past, they were difficult to evaluate because some students could just copy from somewhere. And now students can just let the system create completely new text. Of course, this is not easy to find, but I can also tell you that there are lots of statistical patterns in ChatGPT output that we will exploit to see that this is not really likely that an average student has generated this text. Think about the number of typos that are just too small, the grammar, even strange grammar rules from the English language are in ChatGPT, but not in the average student, especially not in Germany. So there are so many things that make it even difficult for students to cheat with ChatGPT. So it's not a real issue, I think.
So you wouldn't say that ChatGPT will influence the way of teaching?
Most likely not, because as long as we can't integrate this in our teaching platform, so it's all a matter of energy consumption and cost. So if we had a ChatGPT, which would be integrated into, for example, the TUM Moodle, and all the information we have there would be sufficiently annotated, so with 2 steps, it could be a major impact. But if we have like a closed platform of dead PDF files, I don't know what the chatbot would help, actually. Because, yeah, the study program makes clear what to learn when and so on. So I don't think it will disrupt anything there.
This is maybe a kind of a personal thing, but you probably already have experimented with ChatGPT yourself, right? Was there any instances where you found something that they produced that was very cool, or have you made experiments? Because you have maybe a bigger insight in computer science, so maybe you could have tried to exploit some little things or try to trick it.
No, actually, I was just asking some questions that are somehow covered by Wikipedia. And it turned out to be quite good even in understanding what's written in Wikipedia. So like all the negations that have been a problem before, right? You have a long paragraph in Wikipedia telling you what a certain thing is not. But if you just learn the article as a statistical learning system, you will attribute very many attributes to the thing. So it worked out quite well. And sometimes it just said completely strange things. And most of the strange things actually I also just found in the press. Like the system claiming that GPUs are always slower than CPUs or something, because they, it like young children, ChatGPT mixes up things. So you can have multiple statements that are correct in a certain context, but when they are mixed up, they don't make any sense anymore. And this happened sometime. But I was quite impressed from the text quality, so more looking into the grammar and into like, does it get all my negations? Does it get all my context? Like, does it really refer to the previous question? And this was really impressive, that it was not kind of losing track of our chat.
What is your personal opinion about what we can expect from the future?
In general, or in terms of ChatGPT?
In terms of ChatGPT.
I think we will go this path for quite some time, that multi-billion-dollar companies will invest in some startups that show that some things would be possible. But we've seen this before, like IBM Watson is a huge investment, and it was a huge hype kind of claiming to remove lots of stuff from everywhere because it can do everything, but in the end it has not turned out. So as long as we don't have efficient models and explainable models, I think it won't change our society so much, because you can't trust on the models at the moment, and therefore they can only be used for explorative tasks, like a student navigating the internet or a web search, yes, but an automated system taking decisions, no. So there is not that much value you can immediately get out of the system. Maybe if you have some newspaper, if you just want some realistic text, so then maybe it's a point.
I mean, that was parallel to Microsoft is like the second biggest investor into ChatGPT as well. Could you maybe imagine that Microsoft would love to put that into their applications? For example, having a Word application which would already pre-write a text. So you would open the thing, you would have a search a topic or whatever you want to have, and it already writes a text. And I think they would optimize it in a way where maybe they could even insert like a insert typos or something, which could make things completely indistinguishable. Do you feel like that could be somehow
Yes, most
possible?
likely. Of course. I mean, you know that modern versions of Office already have a full integration with the Bing search engine. You can insert images based on topics, based on licenses, and so on. And of course, it would be very helpful, actually, if the word processor would listen to what you're writing and would immediately, like in a sidebar, provide you with images, illustrations, references as a scientist, whatsoever. And as long as it's not kind of taking decisions for you, it can be a great support system. You can have a paper or a web page, and it can tell you in one sentence why you should read it, and then you can decide. So I think this type of assistant will get into these systems, but at the moment it's just also too expensive. They won't be able to provide this on scale for every user of something like Microsoft Word. So it will always be like someone has to pay for it. The main problem with AI at the moment is the fact that we are playing around with very narrow aspects of AI. So we are able to see things as a computer vision community. Had some breakthroughs and something, and everyone calls this AI. Now we have a breakthrough in text processing, but it's in text processing. What we don't have is any sort of general AI, any sort of artificial system that's able to abstract concepts, that's able to find short explanations, that's able to somehow really show sustainable learning and sustainable explainable self-development. And therefore, at the moment, lots of AI is kind of bound to a use case. And that's bad, in my opinion, because it suppresses lots of research, right? There are thousands of PhD students trying to work with images, for example. Yeah, there are thousands of aerospace students in the world just trying to detect red boxes for navigating a drone. What if we could invest just half of this workforce into trying to find out a more sustainable model of vision, trying to push this a real step forward? So all these things are then also a bit overheating, that inside these narrow aspects and inside these domains that kind of emerge from AI, like computer vision, a lot of effort is not going to exchange with other domains. We currently see a trend or an experiment, let's put it this way. Lately, the vision transformers have got interesting, which is kind of trying to translate from the success in the text mining with transformer models to computer vision, but still it's just two of the domains. So behavioral AI and general AI is just far away, and we are focusing too much on perception and not so much on logic, thinking, ruling, and all the traditional types of AI. So then I think we will see a shift there, because I mean, sooner or later systems can see and systems can talk with us. I mean, it's great for a user if you have some chatbot that's really good, right? It feels good. But if the system is not overall intelligent, it also not really disrupting. So.
But what does intelligence mean in a sense? So,
we could go into definitions, but for me, it's very simple. If a system is able to adapt and to learn from few examples, similar to how human beings and animals are able to adapt to reality, then this is an intelligent system. It cannot be intelligent to waste lots of energy just in order to generate some text. Yeah, for the environment, it would be much cheaper to write, for example, these small paragraphs that ChatGPT can generate with some random people. Yeah, I mean, you also see this very often when you think about AI, Mechanical Turk, for example, right? Or like in the internet, you can pay people for very simple tasks just because it's cheaper and it's more efficient and also more correct to let some people do some annoying tasks for some time than it is to kind of build an AI with lots of engineers, and in the end you don't know what you really get out of it. Yeah, you also see this here with mapping in Geodesy and also in Aerospace. The map has to be accurate, so very often it's drawn by hand. A person drawing a map is not really expensive, but it's really smart. And if something is wrong, and let's say someone dies of a map error, like an airplane crash because the map was wrong, right? A really extreme case, you can still trace this back to a person doing a mistake, which is very easily accepted by society. We're used to it, right? This is, in German, this is menschliches Versagen. So this chain of trust is something that you are also kind of missing when you turn something to an AI-enabled system. Who is responsible, and how shall society accept the wrong decisions that systems will make? So I think there is some things to it, yes.
So you already mentioned your research. After the break, we're going to talk about it, and now we are hearing Marius.
The second level of university politics relates to the study program as a whole, and often even the professional profile, meaning all study programs that are related, such as Bachelor and Master Aerospace. On this level, a lot of committee work occurs in order to ensure the studying experience the students of the study programs get is the best it can be. Some of the most important committees on this level are Quality Management and Extended Quality Management, to ensure that everything is going as planned. Accreditation and re-accreditation of study programs, to make sure that the rules and structures on how the study programs are built are sensible. The Board of Examiners, to make sure all exams are fair and handled according to the rules that apply. Some of the distribution of study grants to fund tutors and interesting practical courses. The representatives in these committees put in a lot of effort to prevent larger and structural issues from occurring and fix those that still happen by close cooperation with administration and professors.
Let us talk a little bit about your research. Can you explain to us what one can understand about big geospatial data management?
Yeah, in essence, it's the question of how we should deal with geospatial data. So this is just some data that is related to space and time. How we should deal with this data if traditional techniques that are typically limited to a single computer, like a single server, are going to fail. So it's just asking how can we use multiple computers to solve the problems we have solved in the past for smaller instances, for example, in real time or fast enough, depending on the situation, and also how to cope with the incoming data streams. When you think about autonomous driving and especially test driving in these days, the sensors generate a lot of data, and this data has to be somehow processed, hopefully quick enough to kind of interact with the system. So within minutes, within seconds, you want to have some decision, some results. So it's just all the families of computational techniques that let us use large geospatial data in whatever form we have.
Do you think, or are you working right now on autonomous driving with geospatial data management?
Not directly, because we are much more foundational, right? We are not working on these applications. We are working on the tools that allow such applications. For example, we are working on point cloud management. This is just one example that's very much related to autonomous driving. What happens when you have lots of points from your sensors, for example, from your cameras in the car or from some laser scanners? You generate lots of information per car, millimeter precision, because the car shall be very correct. And then you have some 10,000 cars, and they shall exchange information like the street is different than the precision map. There is like construction site going on or something, yeah. And you just want to exchange this information, so you have to find this information in real time. You have to compare it to existing databases. You have to send around some information about changes. And everything should be done in real time. And in the end, of course, you also want to extract some value. So you want to have a precise world map in real time. So this is kind of the vision. What we are doing there is, when you think about point clouds are currently in the point cloud community processed by individual computers. So they can handle a few million points, but that's it. But they are generated on societal level in the billions. For example, one of our challenge data sets is a data set of the full Netherlands. It's like some more than 10 billion points. And we want to work with this data. Now, people have started working on this data. For example, some computer graphics people from other universities, and they take this data, they take some hours, they organize the data, and then they can show this data set in the browser. So pure visualization now has a delay of many hours. And of course, this is good because you can at least show this data set. It was impossible before. But it's, of course, not really useful when you think about like a digital twin of a city, like all the cars deliver all the precise information to some central location, and you can see like a model of the city. So we are working more than on this abstract data type, like a point cloud. And by providing computational facilities for these things, like point clouds, we can actually help these applications.
And on topic of visualization, you had also presented this concept, which is called GlobiMaps. It also kind of implemented the visualization of the data that you would get on the map as well, right, to some degree or not?
Yeah, you're completely right. You can use it for visualization because it's so nice that you have this multi-resolution access to the system. But the key idea was a very traditional big data challenge. It was from DLR, actually, when we were there, we had this social media stream, right? All the people in the world sending messages 24/7, and you had like some pikes depending on the time of day, the local time. Yeah, there was of course a US pike because there's so many Twitter users in the US, and then kind of the points that we were collecting were walking around the Earth, and so we received data from almost everywhere at almost all times. And one idea, as I said, was to use social media in remote sensing. So we wanted to find out in the first step which of these social media messages are actually originating from highly urbanized area. So we wanted to just say, is it urban or not? Does it come from a city or more from a rural area? And doing so with traditional methods would have been impossible, rather impossible, because for each message you're getting, you have to look into completely different location on Earth. So either you hold all the Earth in your main memory in order to do this, or you hold all the social media in main memory. Of course, both at the same time just doesn't make sense. So the GlobiMaps was just an idea to say, no, we don't need actually this information where the buildings are in a way that we can add it. We can forget lots of structures, but in the end, we need a data structure that's small enough. Small enough in this target was just a gaming PC, so we were heading for 32 gigabytes, something like that, for the whole world, and then just following the social media stream, because this was more natural. We were anyway listening to the social media stream in real time. We wanted to augment it in real time in order to give it to upstream applications in real time. And this is where GlobiMaps just came from. So we just were able to represent very complex geodata sets that would have been several hundred gigabytes in size with just 1 bit per pixel in 32 gigabyte main memory for the global dataset, but even with just a few megabytes for a European version of the dataset, so that we could send it around via email. This is always what I'm saying, right? When you ask DLR people, can you give me the dataset? They will send you a link if you're lucky, or they will ask you for a hard drive. And just saying, no, you can just send this as an email. And I said, no, this is just too large. I said, no, we can do this. Here, read this paper. It's just a few megabytes. So, and the consequence of these foundational questions, we were doing social media mining, and we were trying to somehow solve our problem that the data was not well ordered, right? We did 2 different orderings. But of course, you can also think about sending such data sets to a satellite in order to task it. You don't need to describe the regions where the satellite shall do something. You can give a very, very precise description of geometric patterns or of pixels you are interested in, and thereby you could get much more out of your satellite missions, and you can have a much more complex tasking pattern for Earth observation satellites than you have today. Today you just say, this city, please, an image, and yeah, you can just collect an image. And it would be nice to just focus on sub-images. And so this is why it's also related somehow to aerospace and to embedded, because if there's a complex data set and we can make it ridiculously small, of course we can also put this into small devices, and yeah, maybe this helps then.
So in a sense, you're getting rid of a lot of data that would be collected anyways, but you just kind of throw it away and say this is not important, and we get most of the information out of this part of the data.
Yes, actually what we are doing technically is we introduce some errors in order to save some time. So simplification through errors. And then we just count the errors. And when we realize the errors are not relevant or the errors are very small, we can just have the simplified version of something and the errors, so just an additional error database, and this worked out quite well. And we actually also used AI for that. So we could actually say, okay, let's have a very aggressive data structure. It generates a very noisy version of the original data set. Lots of errors, 10% error on top of the real data. And then let's just use AI to remove all this noise. So we just train AI because our errors are normally are uniformly distributed in space, so we could find them. And this worked pretty well. With just a minor remark, it has a bias, so it would also remove small islands and things like that, because it looks like noise when there's a small island in the ocean. So again, if you use AI, you will have such biases, you will have such problems, and you have to cope with them. So this is also why we in the foundational research then say, okay, this is the data structure. These are the errors we are doing. You can do a correction, which is expensive, or you can do like a rough correction with AI, which is risky. And then we give this to the applications and they have to decide depending on what they are doing.
And whom do you give this to? Like, who are the people applying these?
I mean, as on science, we're giving it to our community, to the...
So it's open source? Or?
It's open source, of course. More or less everything my professorship is doing is open source. Less only if the code quality is so low that we can't show it to someone else, and if there are some barriers like patent applications running. But sooner or later, everything is published. And GlobiMaps from the beginning on is fully open. And we also try to make all these techniques open, of course.
Is there some use for industry? So are there some applications?
Yes, as I said, for example, the space industry can have more intelligent ways of tasking things. We can also think about it. I mean, there's currently a patent walking through TUM, so we filed a patent lately where we use a related technique, so a similar data structure and a similar pattern to organize mobility data in cities, which is also one of the challenges. When you think about, for example, a taxi movement in a city, you want to observe that in order to understand that you're a smart city, right? You ask the taxi drivers where they are, and then you want to find out just, let's understand how the taxis are commuting between the airport and the city center. So you can do two things. Either you ask for all the taxis that are in the airport and in the city center, so you will find just all taxis, not very interesting. You can also ask for all taxis that ever have been in the airport, it's all taxis, and you can intersect it with all the taxis that are in the city center, it's also all taxis. So it just doesn't work so much. So what you want to do is, okay, let's look at one taxi example, driving here, and you want to ask how many taxis are actually taking a similar path. And you want to select them. And this is called a range query. And this is very difficult for these non-local objects because, again, you cannot just throw away all the data. Yeah, you have to compare it more or less with all trajectories of moving objects just because they are so near. So what we do is, why we have very good techniques for trajectories where the start and end point are different, we extend them to trajectories where the start and end point are more or less the same, like from the airport to the city center, and we give just efficient algorithm for finding similar trajectories, and then you can just take one example, find all similar ones, remove them from the database, and ask any other drivers what are they doing actually, and then you can kind of try to understand your data set. So yes, there are applications, and yes, they are maybe for industry or maybe for our startups. We will see. They are currently under patent investigation.
Is the efficiency of the algorithm limited by only the computation power or also the storage? Because in a sense, you say that if you have more data before, you can bounce from that data and kind of already take that information. But if you have deleted data because you need more storage, you have to kind of process some things or not.
Yeah, typically the amounts of storage and things like that, they are not so problematic today, because when you set up some cloud native system and you have enough money, so might be that when you do business case, it gets problematic. But in general, our systems are, or we try to make them linearly scalable, so that kind of, if we have more data, we just have to double the amount of compute. So we just have to double the amount of money, basically, we invest. And this works out to some barriers, like typically I say about 1,000 computers in the cloud, but more than 1,000 is really tricky, it doesn't work so well. Then you have to go from the cloud computing to the HPC, like SuperMOOC Next Generation, where you can have more computers. So the scale problems typically do not really appear in this form. It's more about getting the related data into the right place. So you have a user that's interested in data that's somewhere in your system. Maybe 1,000 computers have to contribute. You have to organize that. Or maybe you have organized all your data very nicely. Yeah, you have 1,000 computers, you organized your data, and then there's an earthquake in a completely irrelevant region of the world. And suddenly, all people of the world want to have geodata from this location. So you organized your system to be very stable, and you have like one computer taking care of this area. Then an event happens, and everyone just wants this single area. So you have to be elastic. You have to kind of, in real time, you have to reschedule how your data is organized, because the interest of people is unpredictable.
Is there any, so can you give us some like maybe simplified methods of how you approach that? Because of course it is probably a very complex topic, but maybe you can kind of give an idea of what are some approaches to sorting that data elastically, how you would say.
Yeah, actually, it's not that complicated actually. In the beginning, you say, okay, all the data needs to be in a place, right? That's clear. So we need places, and when you buy like 10 computers, you have 10 places. But that's not very flexible. So the first thing you do is you divide your computer into lots of places. So you create some sort of virtualization layers that every computer has like 1,000 internal small representations. So then you have like with the 10 computers, you have 10,000 locations. And then you try to predict user behavior, or you come from the data side, you somehow distribute your data according to the pattern you have. And then the system is idling. Typically, IT systems are almost always idling. So we will use that time. There are so-called gossip algorithms from the 1970s. Every computer will just talk to every other computer, telling something that might or might not be interesting. And every other computer will just store this information, integrate this into the local indices. And like in this way, the information will just kind of float around. And then you can let this exchange of information be influenced by users. So like if there's a query from a user, if something is interesting, then maybe this one query will instruct 2 computers to do something. And when the query comes again, maybe 4 computers are asked to do it, so that in the end, after you've seen enough queries, all computers have learned silently how to do it and can kind of contribute to the queries that are coming. So it's kind of a mixture of random communication and the ability to remember things. So you need some additional storage for that, of course. And the tricky part is typically predicting the user behavior, predicting the next time so that you can prepare, because it doesn't help when you communicate at the moment that the user is acting. You have to do this beforehand. That's the principle. And then when you go into implementation details or into proving some properties of the system, then it gets really difficult.
I can imagine that. We probably have more of an X course which goes rather away from research, but more of a conceptual idea of data itself and what it represents in our society nowadays, because somehow it had a big shift between what data meant back in the days and what data meant nowadays. Because, for example, when you talked about taking all the social media data, we can talk about the fact that even if you gather anonymous data from a person or from a large group of people, you still have a huge amount of knowledge about every single person, and you can exploit that in a sense to do something or manipulate them. Or certainly, for example, Cambridge Analytica had the data from Facebook users while the elections, and they used that in a sense to kind of manipulate or put the elections in the favor of Donald Trump, for example. And that would be somehow an application of data which would go in the wrong direction, and somehow it has become a power outlet or a currency somehow. And how is your view on that, and how do you think we can combat that or kind of steer in the right direction?
Yeah, I mean, data ethics is a topic that's getting more important. Many people are realizing that the way it is at the moment is not very sustainable and also not very transparent. In general, I think that sharing data for services is required. I'm a location-based person. If you want to have a map, or if you want to have some Google and you want to find some grocery store and you enter GRO, you want your smartphone to propose some grocery stores because you don't have time to tell where exactly you are. So when you want this type of personalization, you have to share data. The question is what happens to this data, and with which entities you want to share this data. And this is a debate that's going on. I mean, typically at the moment, you're sharing all your data with your mobile phone operators and with your mobile phone software vendors. Yeah, they know where you are and they know what you're doing, and they are sharing this data. They're doing marketing on top of that. And also, from this data, you can infer a lot of private information. But we also have examples where it's not such a commodity. For example, when the New York City was opening the taxi movements, they wanted to have a more transparent market so that taxi drivers could find out where to earn money, where to be when. So they started publishing all the trips. Not real information, it was just some license plate information, the price of the trip, the time of the trip. And we in research did lots of funny things with that, like trying to find out the patterns of the city, trying to understand the traffic dynamics. So you could do great things with it. It was one of the data sets that was used a lot. And then you realize that when you combine this with social media, what people actually did as well is you have some celebrity, and the celebrity gets out of some hotel. You have some fan taking a photo, posting it to Facebook or to whatever social media. You have the license plate of the taxi. You know where this person is driving. And then you can find out where they have been driving last time. And when you scan this data set for such information, you find like some red light events that maybe the people don't want to share, where they have been for that evening, or even also private information where they are living. And this happens just because no one could imagine how you can abuse this data set. I mean, the taxis of the city, they are not that private, right? So it doesn't have to protect private information, because any information can reveal private information for someone else. And this is what data ethics is about. It's about how we can avoid collecting data. That's the first step. Yeah, we don't need this data. Yeah, but there's some data, as I said, if you want personalization, a system needs to know where you are. So there is some data that we will be collecting. How can we deal with that? How can we make sure that this data is used in the right way, not in the wrong way? And in my opinion, it's just a societal challenge. And the key is education. First, people have to understand that it's not good to share this data, or have to decide whether it's good. So we can also do this without any values. When people have realized that, they need to have the alternatives. You were asking me for DuckDuckGo. It's a search engine, yes, but that's also everything you can do for it. It's not fit for my purpose, because it's not trained on my background. I'm a Google user. Google is trained on me, so I'm much faster with all the Google search because it just knows me. So I would not change away from Google, and at the moment, at least not to DuckDuckGo, because the level of personalization my Google search has is just strong for my everyday life. And this is something to keep in mind, and we are working on it, for example, that these platforms have to exchange data since quite a while, and it's getting better. You can change, download your social media, can delete the data. And then there's a last thing, that last misconception. Sometimes people fear the large anonymous entity like Google. Google is bad. You hear this very often. But I can tell you, Google has two advantages over many, many other offerings. They know how to make it secure, and if they fail on it, the company is gone. So they don't have any need of cheating because they have enough money. They have enough money to hire the right people. They have 24/7 security response, and they have kind of the best people in some of the areas to operate such a system. So the end user security and privacy in Google is most likely higher than it would be in an average German company, just because an average German company cannot defend. Yeah, so you also have to think about this large, very large and very anonymous entities. Maybe they are a good host for your data because they are able to do it, and they cannot, they should not, they will not fail on it heavily. And even if they do so, I mean, it's unavoidable, then they have a response team that really acts. So in my opinion, there is lots of things that people still have to learn, that it's not like, let's forbid that Google does these things and let some German companies do it. Instead, this is not a solution to the problem. We need education.
So in your terms, you can say we don't need more safety because Google is already pretty safe and we could just use it, right?
No, that's not what I meant. The point is, sometimes we don't like large infrastructures, especially if they get such a monopole situation or a pseudo-monopole situation, where kind of you say, they have such a good service and no one can build the same service because they don't get the money, because they have to build the service first and then they have to try to get the customers away from Google. No, what I'm just saying is that if you want to have safety in practice, you have to rely on those people that are able to do it. And when you look into the job market and just look into the qualification of the people that you can hire in Germany if you want to build a secure internet company, and that you will find in an average Google security team. So it's more about the limited resources actually. Yeah, so it's not so easy to build an alternative, and this is something you should not kind of overlook. And yeah, sometimes I think that the practical privacy level of Google is extremely high. While, of course, you should also think about, couldn't we have an alternative platform, making an alternative platform strong? Because if we have more platforms, then you have the vector of choice. So at the moment, you don't have so much choice. Yeah, you have Apple, Microsoft, Google, and then there are some Chinese search engines, but more for the Chinese market. And all the rest, including DuckDuckGo, is maybe not yet mature enough to be a replacement for those.
We are currently running out of time. I would love to ask you, though, if you had one advice to give to our listeners, and it would be the last advice you could ever give to them, which one would it be?
Yeah, maybe you just take your time and be yourself. I mean, that's kind of, especially today for students, the most important thing. Don't let the system press you too much. It's your time. Take it, do something with it.
Do you have any future goals then for the next 2 years or 5?
Lots of future goals. Of course, all my PhD students shall do some research and everything shall be fine and all the students shall get happy. So nothing concrete to tell out. We just want to be a constructive group for TUM and for the Aerospace and for the Geodesy departments of TUM.
Thank you for listening, guys.
Okay, goodbye. Thank you.